build a brain dictionary, Jack and his colleagues, Shinji Nishimoto and Alex Huth, used an fMRI scanner to measure exactly how the brain responds to a long series of video clips.
So this is a viewer that allows us to visualize the blood flow while the movie plays. Blue means relatively less blood flow, and red means relatively more blood flow. And you can see that the blood flow is changing quite dramatically as the scenes in this movie play. And the problem that we have in modeling the brain is to try to understand what the relationship is between each individual point in this brain and these movies.
But as they compiled thousands of scans of brains reacting to thousands of frames of video, Jack and his team found that certain objects trigger predictable patterns of blood flow. And they began to build a dictionary of objects in the world defined as particular patterns of blood flow in the brain.
And then once we have this world brain dictionary, we can actually take it and we can sort of run it backwards and we can create a brain world dictionary.
To test that dictionary, they send their test subjects back into the fMRI to watch more movies. Except this time, they don't see what the subject sees. Jack and his team have to guess, using only the raw data from the brain scans and an advanced computer algorithm.
So there are probably, say, 10,000 points on the brain, 5,000 that are being used in this model. And each point in the brain has a predicted brain activity that it generates when you stick an image through it. And then we aggregate information across all those 10,000 points and to come up with the best prediction.
This is the image that only the subject could see. These are the top choices the computer selects from the Brain World Dictionary. And this is the composite average. No matter what the subject sees in the world, the Brain World Dictionary can produce a rough copy. But this algorithm does more than just guess what images people are watching. It can also guess what they are thinking about those images.
Here on the left is the movie that the subject saw, and on the right you can see 2,000 nouns and verbs, and they change their size, and the size of the word indicates the probability that that concept appeared in the video at that time. So you can see here it gets talk, face, woman, man. Here, talking, man. You'll see here's hand, room, face. So this is a complicated scene. Here we go. We switch to an ocean scene, clouds, sky, vegetation. This is Waikiki, body of water, building, sky, people walking, tree. These are all really very accurate semantic decodings.
Jack's team has built a dictionary of 2,000 emotionally neutral concepts that people might think when they watch their series of videos. Calibrating their computers to decode more personal meaning is only a matter of time and increasing the level of detail in the brain scans.
We're constantly surprised by how much information we can recover, especially given that the measurements we're taking of the brain are still at this point really, really primitive. That's one thing that I think is really exciting about this field and really interesting, and I also think it raises a caution flag that I think we're going to have to deal with these ethical issues involving brain decoding sooner rather than later, because we don't know how fast this technology is going to progress. And that opens up a big ethical can of worms. You know, when is that going to be used and what can it be used for? And I really think this needs to get addressed right away.
Brain hackers may soon be able to read your every thought. What then? If your thoughts can be decoded, could they be altered?